always very important. So, a couple of things. Please put those goggles on. Excellent. And we already said what goes up must come down, right? Like possibly on his head. We don't want that. So here, come on over. Put that on your head. Very good. That's all right. Stand right over here. Now, to get our lifting charge going, we need something, starts with the letter C, it ends in bustion. Combustion, very good. All right, so for combustion, we need three main parts. First one starts with the letter F, something you put in your car. Fuel. So I've got my secret rocket fuel here. Spray a little bit in here. Now my next ingredient starts with the letter O. It's all around us right now. We need to breathe. Oxygen. Why don't you put a couple breaths in it. All right, good. Now, what I want you to do is hold the bottle and just sort of swirl it around in the air. Just move it around. And what we're doing by spinning it around here is getting that liquid, keep going, getting that liquid fuel to sort of vaporize and turn into a gas. And there's one more very important thing we need for combustion, and that is fire, or ignition, right? Now, I also need an aerial display shell. I need something to physically launch. So I've got that right here. So let's see here. Let's take this. All right, we're going to spin it around, put it right there. Why don't you come join me back here? We're going to set our aerial display shell on there just like that. Oh yeah, the other thing about aerial display shells, do you guys think that pyrotechnicians stand right next to them and light them? Isn't that a good idea? No. All right, so what is this green, crazy squirrel looking thing on the top here for? What is it? The fuse, very good. All right, so we need something a little bit longer than just simply a lighter. So our fuse is going to be one of these. Hold on to the end there. This is something here at the Franklin Institute we like to call a chicken stick. Why? Because it's a stick that has a chicken on the end of it. All right, now, you guys are all going to help the two of us out by giving us a nice loud countdown from 3. Here we go. 3,
3, 2, 1.
There we go. Excellent. Big round of applause. All right. And we've had our fire display.
Those are jokes.
Was that really an aerial display shell? Now, he happened to miss the grill at one point, and some of the saltpeter fell onto the open flame. And he likely would have seen something that looked a little bit like this. Pretty cool, right? Guys want to see that again? Yeah, I thought so.
Again.
Now, he would have thought that would have been pretty interesting, right? Imagine 2,000 years ago seeing that for the first time. Now, about 1,000 years later, the Chinese started trying to take these simple fireballs and turn them into bigger physical explosions. One idea they had was, what if we take this fireball and we trap it inside of something? Now, they likely about 1,000 years ago would have been using something like bamboo, hollowed out, stuff your stuff in there, and ignite it. But we don't have any of that. We actually instead have a cheese ball container. Don't worry, I had all the cheese balls for lunch, so it's now empty and has a now lit candle inside. We're going to take our lid here, very important, and put that on. And let me see here, do something a little bit like that. So now, the air that's inside of the container, as well as everything around us, is made of these tiny parts that we call molecules. As molecules become warmer, as they heat up, they speed up, they start to move faster, and they spread out from each other. So as materials become hotter, they get bigger. Here's the problem with our container. It's got walls. It has a bottom. It has a lid. That means that that air can't expand. And since it's trying to expand but hitting the walls, this builds pressure inside of our chamber. Eventually, the lid cannot handle that pressure anymore and it blows off the top. This is why that heavy paper on the outside of the shell is so important. Because the more that you have and the thicker it is, the longer you can contain those expanding gases, the more pressure builds inside the shell, and the bigger of a physical explosion you are going to get. So, would you guys like to see that one more time?
Yes.
Yeah, I thought so.
Yeah.
So, keep this in mind. We are producing lots of heat from our fireball that we are developing on the inside. As the heat from that fireball heats up the air expands, it takes up more space. There we go. Causes pressure to build inside the shell, and does this. Blows the lid. Now, do you guys like seeing fireworks shows during the daytime? No, I didn't think so. So do you guys want to see colors with the lights on?
No.
No, right? So let's take a look at some colors with the lights off. Now I'm going to tell you what each one is, and then you are going to tell me what color you see. So our first one here is something called potassium. What color do you see?
Purple.
Purple. So if you guys see a purple firework, what do you think is inside?
Potassium.
Potassium. Very good. Let's check out our next one here. This is something called strontium.
Red. Red.
So if you guys see a red firework, what do you guys think is in it?
Strontium.
Strontium. Very good. Our next one here is something called copper. So if you guys see a green firework, what's inside?
Copper.
Copper. Very good. That is lithium. What color do you see? You guys see pink. So if you see a pink firework, what do you think is inside?
Lithium.
Lithium. Very good. That's kind of strange because the boom primarily comes from the bursting charge exploding. So that's the first thing that happens. Why is it that we see the firework before we hear it? Any ideas? Yes?
Light comes before sound.
Exactly. Light travels faster than sound. So the light being emitted by those stars in there reaches your eyes before the sound of the bursting charge going off reaches your ears. So I thought it fitting that we end our show today with our own version of the last word. Does that sound pretty cool? Yes. All right, now right over here, I have this lovely pink balloon. What's inside of my balloon?
Helium.
Helium. Wrong. Hydrogen. Very good. So helium and hydrogen, very, very similar elements. Both are gases that are invisible, that are less dense than the air. So if I fill a balloon with helium or hydrogen, the balloon will still float. Both the same, either one. The difference is if you pop a helium balloon, does anything happen? No, it just pops. Whereas hydrogen, in particular, if I pop it, let's say, with a flame, it is a little bit more explosive. All right, now, because I can get a little timid during this portion of the show, I could use one final pyrotechnician to help me out. Why don't you come on up here? Come on down this way. Come on over. And what is your name? Sarah. Everybody say hi, Sarah.
Hi, Sarah.
Everybody say bye, Sarah.
Bye,
Come on over, Sarah. Sarah, what I need you to do is put these goggles on. And I would like you to put these earmuffs around your neck so you can still hear me. Okay? Now, since this thing is going to explode, just like before, do you think we want to just use the lighter here? No, right? We're going to bring our chicken stick back. Very important. Now, Sarah, come on over here. So you're going to stand back here with me. We're going to do a practice run of this first, just to make sure you have an idea of how this is going to go. So hold on to the stick here, and we're just, keep your feet still, but you're just going to reach the stick out, actually step just a little bit closer. And we're just going to gently touch the side of the balloon, just like that. Seems simple enough? All right, you put those earmuffs on. You guys should probably take your hands and cover up your ears, especially if you're not a huge fan of loud noises. I'm going to bring the lights down a bit. Now, this is not just a hydrogen balloon by itself. I put one of those 4 salts that we talked about before inside there along with the hydrogen. So when it goes off, you're going to see a color. And afterwards, I'm going to quiz you guys to see if you can remember what element that was that's in there. Here we go. We need a nice loud countdown from 3. 3,
2, 1.
I will take those, man. I'll back you. see?
Red.
Red. Excellent job. So is that cool? Yeah?
Kind of.
You guys want to see another one? Yeah. Sure. Yeah? Okay. Hold on a second. Let me just run to the back here. Now this one I'm going to do on my own, but I put something else inside of this balloon. Something you guys haven't seen yet. You guys want to cover up your ears one more time? Here we go. Countdown from 3.
3, 2, 1, 0. Wow.
Did you guys all see that nice sparkle? That comes from something called magnesium. So the next time you guys see a fireworks show that has sparkle to it, what was inside? Magnesium. Magnesium. Very good. Thank you guys so much for coming by. Check out the